Next, I want us to talk about some applications of logarithms and exponential functions. So in earlier chapters, we've looked at the simple interest formula, which is if a principal P dollars is borrowed for a period of T in years at an annual interest rate, the equation for the interest charge is I equals PRT. So interest can be paid annually, like in I equals PRT, or it can be compounded biannually, right? So biannually is twice a year. Interest can also be compounded get paid out quarterly, such as 4 times a year, or monthly, even daily. Sidebar, you should know that some banks use a 360-degree day year, which I know makes very little sense, but it's what they do. It's more evenly divisible by 12. Now, compound interest is when you take the interest due at the end of a pay period and you add it back to the principal. So now the amount of money in your account has increased and you begin to earn interest on that principal. So the interest compounded the next pay period is on the new principal, which was your old principal and your interest. And compound interest is the interest paid on previously earned interest. And this is one of the best ways for bank accounts to like savings account, or when you get a 401k, this is how it's going to be earning more and more value. So the compound interest formula uses exponents. So the amount A after T years due to investing principal P at an annual interest rate of R that's compounded n times a year, so like 1 for once a year, 2 for twice a year, 4 for quarterly, right, is A equals P, hi Bobby, times 1 plus R over N to the NT. And we refer to A as the accumulated value and P as the present value or the principal, the initial amount you put in. And Bobby's very excited to learn about this topic. Yes, she is. So let's compare compounding periods. So if I were to invest $1,000 at an annual rate of 10%, what would the final amount be in my account after 1 year if I compounded annually, semi-annually, quarterly, and then we're going to go monthly and daily? So I have my equation, which is A equals P times 1 plus R over N to the NT. Now, if we're compounding annually, my N is 1. So my final amount is going to be my principal, which is $1,000, times 1 plus my rate, which is 10%, so 0.10, divided by N, which is 1, to the 1, which is N times 1. So we're just going to write to the 1. This would give me an amount of A equals $1,100, right? 10% of 1,000 is $100. Now, what if I compounded my amount in my account semi-annually? So N is 2. So I'd have A equals 1,000 times 1 plus 0.10 divided by 2 to the 2 times 1. This would give me an amount of $1,102.50. So right, already $2.50 more than we made if we just compounded annually. What if I did this quarterly? So N is 4. I have A equals 1,000 plus 0.10 over 4 to the 4th times 1, because my time in years is just 1. And I'd get A equals $1,103.81, right? So as you can see, the more we compound it, the more interest we earn. What if I was to compound monthly? So this means my N is 12. A is 1,000, the initial amount invested, times 1 plus the rate divided by the number of times it's compounded to the number of times it's compounded times the number of years. I get A equals $1,004.71. How about if I was to compound this daily? A is 1,000 times 1 plus 0.10 divided by 365 to the 365 times 1. That gives me an amount of $1,105.16. Other than compounding a fixed number of times a year, we can also talk about continuous compounding, and this uses the handy dandy E we talked about in previous chapters. So the amount A after T years due to principal P invested at an annual interest rate of R that's continuously compounded is A equals P e to the R T. So I have my amount, which was 1,000, to the E, to my rate, which is 0.10, to the T, which is 1 year, and I'd get $1,105.17. That is only 1 cent more than if I compounded daily, right? When we compounded daily, we had $1,105.16. Now that I'm compounding continuously, I get an extra penny. Now, you can also use the compounding interest formula to solve for initial principal or the present value. So what amount would I need to invest to get $3,500? So this would be my final amount after 7 years if I invested at 0.03%, so that means my R is 0.03 interest, and compounded semi-annually. Semi-annually means twice, like semicircle, half a circle. So this means I have $3,500 equals P, which I don't know, I'm trying to find out, times 1 plus 0.03 over 2 times 2 to the 7. This means $3,500 is P times 1.015 to the 14th. So now I'm going to go ahead and divide both sides by 1.015 to the 14th. This means I get P is $841.47. Now, when you solve this, you get more than 2 decimals, but because we're dealing with money, we always want to round to the hundreds place.